Hello everyone. So today let's solve a problem on MATLAB Simulink. So the problem goes like this. Simulate a car's motion that undergoes different phases of acceleration. For the first 10 seconds, the car has a constant acceleration of 2. For the next 10 seconds, it has a constant deceleration of 1. Using a Simulink model, plot the car's velocity and displacement over 20 seconds. This problem uses a switch or if then else block to change the acceleration value based on time. So from the beginning, there are two acceleration phases. So let the first acceleration phase be A1. So what it says is for the first 10 seconds, the car has a constant acceleration of 2. That is for the first 10 seconds. That is for first 10 seconds, the car's acceleration is 2. For the next 10 seconds, it has a constant deceleration of 1. So I'll take the next acceleration as A2. So the value of A2 is minus 1. This minus indicates deceleration. So this deceleration is for time 11 to 20, which means the second half of the simulation. So the total simulation time here is 20 seconds. So the total simulation time is 20. Now the problem gives us an option to use whether a switch block or an if then else block. So let's go with a switch block. So we are going to use a switch block. So what else we need to know is what is the main problem that we are going to solve here is we have to plot the car's velocity and displacement. We have to plot two graphs, the car's velocity as well as the car's displacement. But we only have the value of acceleration with us. So before going into the problem, the basics that we need to know is if we integrate acceleration, we get velocity. Similarly, if we integrate velocity, we get displacement. So these are the basics as well as this is the mathematical model of the simulation that we are going to do. So let's go into MATLAB Simulink now. So if you open a MATLAB homepage, you'll find this homepage here. So now to open the Simulink model, go to new, the drop down menu, and you can see the option Simulink model right here. When you click it, it will redirect you to the page of this one. So this is the Simulink workspace. So let's click the library browser here. So this is where we use all our blocks to build the simulation. So all the blocks that we use to build simulation are here, and we mostly use the blocks under this Simulink tab. So let's get into the problem. So our first thing is we have two acceleration values, A1 and A2. So what I'm going to do is I'm going to use two constant blocks to assume that one constant block is one acceleration and the next constant block is the other acceleration. So for constant blocks, I can directly get it from the commonly used blocks. So in this commonly used blocks, you can locate all types of blocks that most of the Simulink users commonly use. So here is the constant block. I'm going to drag it into the workspace. So now we have the constant block. So I need two accelerations, so I've dragged another constant block with me. Okay. So the first acceleration, I'm going to rename it. Just click on the block. You'll see the name of the block below. Click on that name and you can instantly rename it. So I'm going to rename this as A1. So the value of A1 is 2. Double click on the block and you'll see this block parameter tab open. So in the constant value, I'm going to enter the value as 2. Click OK. Similarly, in the second constant block, rename the constant block as A2. The value of A2 is minus 1, which means the car is decelerating. Right. So now, this acceleration varies based on time. So we need a block which represents time. So for that, I'm going to do is go to Simulink and go to the sources here. In sources, you'll find a block called clock. So I'm pulling the clock in. So now we have our acceleration as well as our time block. So next we are going to, what we are going to use is, as per the question, we are going to use a switch block here. So what we are going to use now here is a switch block. Now to find a switch block in Simulink, go to signal routing tab. So in signal routing tab, you can find a switch block here. You can find the switch block right below here. So this is the switch block. I pull the switch block inside the workspace. So now this, if you take a closer look at the switch box, there are 3 ports here. The middle port is the condition. So whenever the middle port condition satisfies, the input which is given to the first port gets as the output. But whenever if the condition fails, the input which is given in the third port will be given as the output. Clear? So now the condition that we are going to do. So our acceleration changes based on time. So the condition port will be fitted to the clock. And now let's get to the condition. So what is our condition is that when the time is greater than 10, that is for the next 10 seconds only the acceleration changes into deceleration. So let's double click on the switch block and let's change the threshold to 10. And the criteria is given above. You can change the criteria anything like you want. So what criteria I'm going to give is U2 greater than threshold, which means when the time is greater than the value of 10, the car decelerates. So for true, if the condition satisfied, what should I need to get as an output? I should get the output as -1. So I am pulling this A2 block here to the first port, and the remaining block A1 I am going to give it into the third port. So now I have my basic structure here. Now we need to plot both velocity and acceleration, and like I mentioned previously, if we integrate acceleration, we will get velocity. Similarly, if we integrate velocity, we will get displacement. So the output of this value here is an acceleration, because even if the condition passes also, we'll get the acceleration value as output. Similarly, if the condition fails, we'll also get the acceleration as an output. Now we have to integrate the acceleration to obtain a velocity. So to obtain velocity, we need to integrate it. So go to the commonly used blocks. You'll find the block name here as integrator. Pull an integrated block into the workspace, and I'm pulling another integrator block into the workspace as well. So now I'm connecting this output to one integrator block. So now this integrator block provides me the velocity, which means it is integrating the acceleration to provide me velocity. And now I'm connecting this output of this velocity block to the another integrator block, which will give me my displacement. And done. Now we have a complete model. Now we have to visualize the output of the model, and we have to plot the graphs. So for plotting this graph, if you need to plot anything, if you need to visualize a graphical view of a simulation, use the scope block. So this scope block is also available in the commonly used block. Just pull the scope block here. Now there are two options. We need to plot both velocity and displacement. We can use two separate scope blocks for a velocity output as well as displacement output, or we can combine both these signals using a block called mux. So this mux block, it essentially combines two signals to give a single output. So how I'm going to combine these two signals is, I'm going to take the output of displacement block and attach it to the input of one input of the mux block. So I'm pulling it and I'm attaching it to the mux block. Similarly, I'm going to branch the output of velocity signal and I'm going to attach it to the another input of mux. So how to branch a signal is, go to the signal line here, right click on the signal and pull it out. You'll get a branch signal here. Now connect it to the another input of mux block. And now we have two signals combined into one. Now connect the output of mux block to the scope. Now, the most important thing here is our total simulation time is only 20 seconds. So that we need to give as an input. So in the above tab, you can see this option as stop time. So double click on the stop time and change it as 20. Now you're good to go. Now run the simulation. So as you can see, the simulation is compiling and running. And now our simulation is done. Now to view the plot, double click on the scope and the scope window will open. Now let's zoom it in. Now as you can see, there are two lines here. So in these two lines, one represents velocity and one represents displacement, and we don't know what represents what. So to know that, go to scope here. In the settings drop down, click the drop down and tick the legend bar. So now the legend appears here. So the yellow line shows us the velocity. This blue line shows us the displacement. So as we can see, over 20 seconds, the displacement gradually increases. It does not decrease because the car keeps on moving. So it displaces to a certain distance. It does not change. However, the velocity here, initially the velocity rises up to a certain point of 20. But after that, since the car's acceleration is decreased and the car is decelerating, the velocity gradually decreases. So this is the output and this is a Simulink model. Thank you guys.